Welcome to our Brown Bag series, brought to you by HeadHunt in partnership with NUS Institute of Systems Science. Broadcasting live from ISS, we have with us Mr. Edgar Tai, Graduate Recruitment Manager, who will be opening the session and sharing with us on ISS and their stackable programs. I will now pass the time to Edgar. Edgar, please.
Thank you, Tammy. Good afternoon, everyone. I'm Edgar from NUS Institute of Systems Science. Thank you again for joining us for this series of talks. Before we get to the main topic on exposing platform services to front-end and partner services via API, I'd like to take about 10 minutes to share with you about the stackable programs here at NUS-ISS. For those of you who have been joining us over the last couple of days, please bear with me because I think that this is really going to be interesting for you, especially if after hearing the topic, you're interested in joining us for a course, because what we offer is one of the truly stackable programs in Singapore. So this means that you get a lot of control and flexibility over your time commitment. So let me share my slides. Okay, so for NUS-ISS, just a quick introduction to NUS-ISS. We were founded in 1981, so this year we're exactly 40, and we are part of NUS. So that means that we are the #1 university in Asia, and NUS consistently ranks among the best universities in the world. In fact, just a couple of days ago, there was an article that showed that NUS is one of the top 10 universities in the world where the graduates of NUS are highly sought after by employers worldwide. So for ISS, we are a continuing education institute. That means that we do not offer undergraduate courses. We offer short courses, continuing education courses, master's degrees, graduate diplomas, executive education programs. And we're very focused on practice-based education. That means that whatever you study here, you have the opportunity to apply. And it really, whatever you study here really fulfills a job role that is out there. You're not just studying for the sake of studying. We're also a pioneer for alternative education pathways. What this means is, so this is actually the alternative education pathway diagram. What this means is we do not want to leave anyone behind. As you know, for most master's programs as well as graduate diploma programs, there are certain entry requirements. And typically, if you don't meet the entry requirements, then the institution will not take you in. But what ISS has done is that we have designed different pathways for you to be able to join the programs. So there are modular courses, there are certificate courses that when you take those, eventually they stack up to a graduate diploma or a master's degree. So today, I'm just going to quickly share with you what the stackable pathway looks like, how it stacks up to a full master's degree, and of course, to share with you some of the subsidies that we have of up to 40%. So first, lingo. You have to understand that there's this, the graduate certificates, we call it grad certs, and they are modular and stackable. So grad certs, they consist of certain number of courses inside, courses or modules, okay? So you take a few modules or courses, it becomes a grad cert. After you take a few grad certs, that stacks up to the master's degree. And every grad cert fulfills a certain job role. Okay, it will fulfill a certain job role that industry needs. So here at ISS, we also do recognize prior learning. So if you happen to have the right experience or you have the right kind of background, educational background, you can always seek exemptions when you apply. Okay, so the grad cert structure itself, just focus on the diagram on the right. It consists of courses. So the courses take maybe a few days, 3 to 4 courses, 3 to 5 days, 6 days, depending on the course. Okay, so after you're done with the course, throughout the course, we also want you to practice, because you come in here, you learn 3 to 5 days, most people tend to forget what they learn. But just like you cook, when you want to cook something, when you go for cooking school, you cook it once doesn't mean that you're a chef or you're an expert at it. You have to go home, you cook it several times until it almost becomes muscle memory. So you do need to practice on your own, whether it's at work or at home. So at the end of that, there's a practice module exam. So you'll be assessed. Okay, then after you're done with the assessment, then you fully have completed the grad cert. So today's topic is actually from the Masters of Technology in Software Engineering. It's actually from the Platform Engineering. In fact, the grad cert that's called Architecting Scalable Systems. So today's topic will be from one of the modules inside. So this is the full structure of our Masters of Software Engineering program. You can see that there's a segment that is in brown or orange, and then the rest are in blue. So these are the various grad certs that are in the course. And there is a foundation grad cert, that's the one in orange. So that is a mandatory graduate certificate that you must fulfill before you can choose the specialist, choose from the range of specialist graduate certificates that are there, the grad certs that are there. So there are 4 specialist grad certs, you need to complete 2. So in total, to complete the Masters of Technology in Software Engineering, you need to take 1 foundation grad cert, 2 specialist grad certs. Okay. At the end of that, there's also a capstone or internship project. So if let's say you're a full-time student, then you will be doing an internship. If you're a part-time student, then you do a capstone. Okay. So full-time students who sign up directly for the master's program with us, they take about a year to complete the program. Part-time students take about 2 years. And for stackable students, that means that you have chosen to go down the route of taking individual courses. After you have completed 1 grad cert, you will have up to 7 years to complete the rest of the grad certs, the capstone project, and finish your master's degree. Okay, so other than the software engineering masters, we also do offer masters in data science, enterprise business analytics. So these are the different grad certs that stack up to the masters of enterprise business analytics. And then of course there's also one on artificial intelligence, and today's one is on software engineering. Okay, so when you're doing your grad certs, after you have completed them all for your 3 or 4 grad certs, then you meet the minimum cap, then you'll be matriculated as an NUS student. Okay, you can also convert to an NUS student halfway through. That means that you don't finish all the grad certs. Maybe you have only done 1 and you want to convert to become an NUS student. That's also possible. But we'll look at your how you have performed on the grad cert so far. So if let's say your scores are good, then of course we'll convert you and you join the rest of the cohort. If your scores are still getting there, then we'll encourage you to continue on the stackable pathway. So some of the common questions that we get from prospective students, okay, will be things like, is the stackable route right for me? Okay, so there's no right or wrong route. Okay, it's all a matter of your time commitment and flexibility. So anyway, all these routes still lead to the master's program. So it really depends on you. So we do believe that you will need time to practice whatever you have learned. So if you need that time and the stackable route is more suitable for you, then this is something that you should consider. If you can commit to a full-time program, then of course, we also want you in for the full-time program. Some people have come to us saying that they prefer the through train pathway, and we understand that as well. But what we've done is we've created a funnel. So there are many different entry points. Okay, whether you are someone who is already a professional in the field and you want to deepen your skills, or you're someone who's looking to transition into the field. Okay, so there are different entry points, and this is why there's the stackable pathway, because like I mentioned earlier, the master's program has certain entry requirements. The stackable pathway allows you to come in and take any of the courses without much of an entry requirement. But because there isn't much of an entry requirement, you will need to work hard to graduate from the program. So it's not as if you come in, you're guaranteed graduation. We'll take everyone in, okay? But we want you to work hard to graduate from the program. Okay, so the last bit that I have is on subsidies. In terms of course fees, Singapore citizens will get up to 40% subsidies on our course fees. Singapore PRs 20%, international students will be paying full fees. Okay, so that's it for the program sharing. I'll hand the time back to Tammy.
Thank you, Edgar. We will now continue with our brown bag session on exposing platform services to front-end and partner services via API, brought to you by Mr. Darryl Ng from ISS. Now, before I hand over the time to our speaker, please note that there is a Q&A function at the bottom of your screen. Please feel free to type in your questions at any time during the presentation. Please also note that we will be conducting our feedback poll at the end of the session, so please stay with us throughout. So without further ado, I will now pass the time to Darryl. Darryl, over to you, please.
Hello, a very good afternoon to everyone who joined this session. It is my honor and pleasure to share with you on this topic, exposing platform services to front-end and partner services via API. So times are changing. Technology is one area that has evolved. As a result, many processes, businesses, and our lifestyle and habits have also evolved. For example, we used to listen to music on a cassette, CD, or MD player. But now we don't see people carrying a cassette, CD, or MD player around. Music is now in your hands, on your phone. And we listen to music on iTunes on the phone. And now we can even create music on the phone and share it on CloudShare, where everyone is able to search and listen to. So our lifestyle have changed through technology, but it is important for us to realize that technology is only an important enabler of change through a platform. It doesn't automatically make a business a platform. So first, let us understand what is a platform. A platform basically is a set of services on which application can be built and run on top of. So it's a foundation on which outside parties can use to build their products or services. It comprises both of hardware and software. Therefore, you have both hardware, both infrastructure and application architecture. And the key here is how can we engage people to come onto the platform as producers and consumers. This needs to address complex issues such as the discovery of the service, resource coordination, container orchestration, and usage reporting of the platform. So the forces of change today are increased connectedness through the use of devices with increased interactions and tracking capabilities. We see a paradigm shift in the way supply chains are being handled, right? Decentralized operations and production across the different business domain and verticals, decentralized applications. These are powered by the maturity of cloud services, the availability of data and data analytics framework, tools and capabilities, and of course, the rise of artificial intelligence. They are driving a whole new design for business. It changes the way we deliver software on desktop applications that need to install on every single machine with a desktop license to a subscription-based approach, such as your Office 365, Adobe Creative Suite, etc. And it changes the way we also build software using traditional software development methodologies, such as waterfall, iterative, incrementals, to modern agile and Kanban methodologies. Last but not least, it shifts from a manual to a more automated delivery of software using CI tools such as Jenkins and code pipelines in the cloud service. These have brought about changes in business models and operations. In the traditional business model of operations, it is a more linear approach. Value is created upstream and delivered downstream, and the focus is on the process. We see a shift towards a network business model, transiting business from business and business application onto platform, and the focus is on the interactions. In this digital era, we have seen an increased rise in the number of platforms. Based on studies, out of the 160 plus platform business, these are the 8 most popular platform types. Here, we want to take a look at the different components that are present in a platform. Basically, the platform has to serve a purpose. It has a seed or value for the systems. We start with one seed for the platform. And most importantly, it allows both producers and consumer of the seed to interact. And on the platform, most of the time, producers can also be the consumers of the seed and vice versa. Magnet will be the lucrative factors and incentives that are built in through the platform to attract producers and consumers to join or to participate on the platform, such as sign-up credits, points accumulated, credits accumulated, or discounts that you can consume when you use the service. Toolbox refers to the services or library components that enable the interaction between producers and consumers in a platform, such as Expose API for public to develop and consume, or library components. Matchmaking will refers to additional capabilities that are built into the platform, such as data analytics, auto curation of content, AI for pattern matching. In the context of your mobile device, for example, iOS is a platform. The seed is, of course, the apps or the applications. Apple started with a phone having their own apps. So there is a control pool of Apple developers. The initial idea is to draw more consumers to use the iPhone, and that's the manic. Gradually, this was made available to the general public to be the producers of the app. We can see more Apple developers coming in. And the manic to draw these developers will be the increased number of users using the iPhone, the increased number of apps that are available on the phone, the Apple Developer Conference that is held every June yearly. And of course, it is free to develop. The tools are available without charge. And the quality of the app on the App Store through stringent review process. iOS also provide better earning potentials. And we are the consumers. So we have to ask ourselves what attracts us to use our iPhone or Android phone. And each one of these aspects has a big impact to the success of the platform. For example, the domain entities, you have to look into the kinds of information to keep about the seed or the value for the applications. The producer and consumer are also domain objects, and we need to know the demographics and persona of these producers and consumers. How we can enable interactions between producers and consumer through the use of technologies like REST API or GraphQL. And the manic will be actually the attraction or the things that can attract producers and consumer to use the platform. It is more than marketing. For example, in the Apple context, right? Apple gift card is an incentive, right? UI and usability of the phone and applications are important magnet to draw people to use the phone or the applications. The toolbox will be whether your application is mobile applications, whether does it need 2FA login, the internal APIs and public-facing API, and the technology stacks that you use to build on, such as for iOS, of course, is the Quokka framework. In terms of scalabilities, we need to look into how to handle the growth of the seed or to grow the seed. In iOS example, to grow the seed, which are the apps, we need to attract more developers and phone users. We need to bring in the market. And Apple has done this through a very well-defined strategy. Apple ecosystem through its line of Apple products on Macs, iPad, and iPhone. The application is able to work across the different platforms seamlessly, and the apps are designed for high performance on the devices. One of these aspects can be made possible through the use of API. Another perspective will be well-designed infrastructure and application architecture. So to put them into perspective, this is how it is all pieced together. You create your application using some form of framework. This application can be your API application, web application, or mobile application. You may have created common reusable libraries, which are your domain components, using some form of framework that can be used by your application. And this application will make use of services or domain components you have created. Public-facing services will be your exposed API that are developed using some form of framework also, so that you can see that the framework encompasses your application, libraries, and API services. And they are all part of a platform or running on a platform on, for example, AWS, Azure, or Google Cloud environment. And the framework frames the application you build and deploy on the platform. The public-facing API services is one of the enablers for your platform to talk to another or other platform or partner services. And we need to ensure that every feature in the platform adds value instead of creating constraints and coupling. What makes a platform compelling? Some of these key aspects or points that are crucial to drive a good product includes self-service of overwhelming majority use cases. It must contains reusable, composable, discrete services that can be used independently. and it does not force inflexible way of working upon the delivery team. And most importantly, there's a rich internal user community for sharing, and your platform must be secure, compliant, and up to date. So looking at this, we can quickly enable business interactions and agility. One of the key aspects can be done through exposing our platform through API for front-end and partner platform services to consume. This lies with how applications interface through API. The advantages it brings includes separation between the client and the server. The REST protocol will separate the user interface from the server and the storage, and thus improve the portability of the interface to other types of platform, and increase the scalability of the project for different business use cases or applications to consume. And it allows different components of the development to evolve independently. Secondly, there is feasibility, reliability, and scalability. Each development team can scale the product without much integration issue. The separation of concern make it easier for the front end and back end to be hosted on different servers, thus make the apps more flexible to work with reusable services and components. Thirdly, it is independent of the type of platform or language. It makes it easier for other platforms on any language to use through the use of a common format for exchange of resources or data. So what is an API? In simple terms, API stands for Application Programming Interface that enables communication or interactions between software application, systems, or platform, which is what you see on the previous slides. Your mobile app, your web app, your legacy app, your cloud services, IoT devices can interact with one another through APIs. Therefore, it is very important for us to develop API. We need to shift our paradigm on API thinking to have something like API first approach, or API as a service, or API as a product. For one example, Expedia, 90% of the revenue depends on API. API provide a fast and easy way to implement functionality or data from another application into your own. So to successfully create, publish, or manage and monetize your API, we need the right API platform to manage our API, such as an API portal or gateway. For example, Azure APIM, AWS API Gateway, or MuleSoft portal. And it is important that the company consider API as a product if the company is serious about expanding its business, right? The company will actually likely to designate a person to design or manage its API product. He or she will be the API product owner or manager, and he or she will manage the stakeholders, internals or external developers, to come up with an API product strategy that's translate into an API roadmap and translate to the API backlogs. And your API will also have the ability and capability to measure its usage and performance. And we can also have analytics done on the API, not just the platform. For example, the throughput. We can all write API, but it doesn't mean that it complies to certain standards and principles. And API is guided by these 6 RESTful design principles. So to understand these principles, we will take a quick look at each of them. A client will send the request to the server for some data like document, PDF, or image files, or tell the server about something that is happening. Like, for example, user login with his credential. The server will respond to the client with the appropriate result after querying from the database. This is the reaction of the server to a request of the client. For example, this could be fetching data like document, PDF, or image file, or a successful login response. Service, which is a specific task that the server provides for the client to use, like downloading image, retrieving some data from the database. So we need to ask ourselves this question: when do we need client-server communications? Client-server communication is always used whenever someone requests something from the internet. Applications like your Facebook, Twitter, Instagram, Google Maps uses some form of client-server communications to create, retrieve, or update data. The second point we want to talk here, right, is on statelessness. First and foremost, to enable API to be RESTful, we need to use HTTP protocol. The API application is hosted on some web servers, but does it mean that the web server is stateless? What do we mean by stateless? HTTP is a stateless protocol. That means HTTP server need not keep track of any state information. Each API request is executed independently without any knowledge of the requests that were executed before. The connection between the browser, which is the client, and the server is lost once the transaction is over. The client is responsible for storing and handling the session-related information on its own. So things like authentication information, it should be stored at the client end. And whenever you need to call an API request, the authentication is provided. So to enable client to access this stateless API, it is necessary that the servers should include every piece of information that the client may need to create or maintain the state on its site. There are two different types of application state here. One is the application state, which is the server-side data that the server stores to identify incoming client requests or the previous interaction details and current context information. The second type of state is the resource state, which is the current state of the resource on the server at any point in time. And it has nothing to do with the interaction between the client and the server. It is basically the API response, or we can also refer it to as the resource representation. So REST statelessness means being free from the application state. And there's a question that we need to ask also is, what makes REST services to be easy scalable? REST services follow the concept of statelessness, which essentially it means there's no storing of any session data across the request on the server. Therefore, it makes it easier to scale horizontally because the server need not communicate much with each other while serving the request. The second point I want to talk about here is uniform interface. What do we mean by uniform interface? How do we achieve uniform interface? First, let us understand what is the resource. So your PDF files, your Word document, your image, JSON file, your configuration properties file, they are your resources. And basically any type of files, they are your resources. And one of the compliance that will make sure that our API meets uniform interface principle, we need to make sure that our API complies with RMM standards and level. So we need to make sure that our API uses the right HTTP method or verb on different type of API requests. For example, if you are retrieving a list of employee records, the API created for retrieving the list of record should comply to use the HTTP verb get. For creation of new employee record, the API created for creation of employee record should comply to the HTTP verb post. Another key factor in HTTP RESTful API services, our operations such as get, list, always work on a resource collection, and create, update, and delete is on a single resource. So two key things to remember that you should never define a method of verb without an associated resource, and each method must be mapped to a HTTP method or request method. Very important, we need to properly layer our API implementation. So in this diagram or in this slide, we see a 4-layer architecture where we layer our application to core, to application, infrastructure, and presentation layer. The reason why we want to layer this architecture includes the factors and consideration to make sure that we follow some design or principles. For example, domain-driven design, right? That properly layered our entities, repositories, domain, and application services. Through this, we can ensure a clean architecture, applying solid and dry principles in our code implementation for the APIs. The best practices highlighted here ensures loose coupling, dependency inverted architecture, using design patterns such as dependency injection, logging, validation, exception handling, etc. So in REST API, layering actually means that the client will only know the intermediate layer that it's communicating with. Any layer behind, which is the actual processing, such as the logic is being handled, should be transparent to the client. One of the most important principles of RESTful is also caching. The most basic approach to fulfilling REST caching principle is to cache at the API application level, which is the code level. Caching allows us to boost performance in our application. At the code or application level, you specify the caching context. Caching will be managed and handled within the hosting server that hosts the API. The cache data will only be available for the container, that means the web server that hosts the API. There's no way to share them across or the concurrent execution of a function. This means that the overall cache miss can be pretty high. The first call in every web API server will be a cache miss. Other advantages include response data caching that reduces the number of requests to a web server. It reduces the amount of work the web server performs to generate a response. Also, it uses header that specifies how we want to cache response. In-memory caching uses server memory to cache data. So an example will be mock data for unit testing. Alternatively, we could also use cloud services like AWS Elasticache as a form of in-memory cache for your API response data. Distributed or Redis caching technology uses distributed caching to store data in memory for application hosted in the cloud or server farm. The cache is shared across the server that processes the request. An example of distributed cache could be through your CloudFront or Elasticache for different regions. The next concept for uniform interface that makes API RESTful is HeadHunt, hypermedia as the engine of application state. Hypermedia refers to any content that contains link to other forms of media such as images, movies, and text. The presence of hypermedia links in the API response content allows client to dynamically navigate to appropriate resources by traversing through these links. The advantages is loose coupling. For example, if a consumer of a REST service needs to hardcode all the resource URL, the API URL, then it's tight coupling with your service or your code implementation or your application. When the API response returns the URI or URL, it could use for actions, then it is loose coupling. There's no tight dependency on the URI structure. It's specified and used from the response. So it becomes self-discoverable and explorable. The downside, of course, HeadHunt is not trivial to implement. It is not easy to implement this feature. Therefore, we should keep in mind the scope of our API and whether we need to implement HeadHunt on the APIs or on all the APIs. So by adhering to the 6 design principles that we have just mentioned about, we will be able to achieve RMM standard level 2 or level 3 of API design. Our level 0 of RMM basically defines client-server communication with each other using a single URI and single HTTP method. So this can be seen in traditional SOAP-based API, where communication are done through web services, descriptive languages, WSDL, or using a single URI to identify endpoint in plain old XML. So an example of RMM level 0 will be your RPC, your remote procedure call. Right. Level 1 of RMM uses multiple URIs, but a single HTTP method or verb, preferably a post for the endpoint. Here, a single unique URI is given for each resource, making RMM level 1 API better than level 0. Level 2, we will separate the URI given for separate resources. Right? We incorporate different HTTP methods of verb according to the CRUD usage for these resources. So level 2 is the stage where REST principles are being followed by letting business entity or resources be manipulated over the network using different HTTP methods or verbs. Most of the time, when we are able to design and implement our REST API at RMM level 2, I would say that we have achieved a good practice in designing and implementing API. In the next couple of slides, I'll share with you some of the good practices of implementing API. First and foremost, API versioning is very important. We want to support continuous change for published API without creating problems for API consumer. In a nutshell, we support compatible change of APIs over time, such as adding features without ever breaking existing API for consumers. So firstly, we don't want to take anything away abruptly. Deprecating APIs need to be done gracefully. So through versioning and proper documentation, we could slowly phase out deprecating API by providing grace period for consumers or partners to make the necessary changes. Secondly, we don't change the meaning of an existing API. For example, if your API has an input parameter that takes in the filter meaning user count, you can't later change the same parameter to a page count. Changing the meaning of things has the same effect as taking away and replacing it with something else. Additions to an existing API is optional. If your API has an add or insert operations and that only take one required arguments in the initial release, adding a second required arguments essentially take away the original add or insert method, replacing it with a non-backward compatible version. So we want to avoid these breaking changes. So there are some approaches to this, and the approaches to versioning API. Number one, URL versioning is the most straightforward approach, and it's also most commonly used. However, if it's not well documented or managed carefully, it can likely break client integration when a new version is updated. So number two, we could use a custom header. A SEP version, a SEP header allows URI to preserve between different API versions. So content negotiation is done through the request header. This preserves a clean set of URI. It is transparent for consumer to know the different API. So some of these best practices to follow when constructing API endpoints are as follow. Number one, resource should be nouns and not verb. So endpoint for retrieve and saving data is the same. Number two, we use plural nouns. Exception is if the resource is a singleton. So in this case, or in this example, to retrieve the address of a specific customer, we use the following URI format: /customers, /ID, which is the ID of the customer, and the address is a singleton, so therefore it's not plural. Number three, we use kebab case for resource names that have more than one word. For resources that have more than one word, such as order item, we use the kebab case when specifying the URL. So example is shown here for URL kebab case. Number four, use path variable instead of using parameters wherever possible. The example shows URL to retrieve order for a particular customer. So use path variable to specify the customer ID and order ID, which is a preferred way instead, rather than passing them as a request parameters. So most importantly, consistency. Keep this in mind that consistency of API endpoint are very important. So all the URLs that should follow the same set of standard when we define the API at the beginning of development. So it has almost become a de facto standard to use Swagger for API documentation. The Swagger includes specs and tools based on Restful standards. But today, with the merger of Swagger and RML, it has become Open API. What is Open API? It's a public API that, or publicly available application programming interface that allows developers with programmatic access to a proprietary software application or web services. Open API documents are machine and human readable. It enables anyone to easily determine how API works, the standard format to define the request and response structure, the syntax on how to call or consume the REST API endpoint. More often, we use it as a documentation generation tools to generate API specification. But a very important feature of Open API is that it is also a code generation tools. It is able to generate server skeleton stub and client codes in various programming languages. It also is a testing tools and many other use cases. Exception handling is one key aspect that you should also build into the API. Error handling features helps us to deal with unforeseen errors which could appear in our code. The most common way to handle exception is the use of try-catch block in our code, as well as the finally keyword to clean up resources afterwards. In the API project, there's nothing wrong to use try-catch block in our actions. But now, if we were to test simulating an error that occurs with the API, it will still work. But the downside of this approach is that we need to repeat our try-catch block in all our actions or API functions in which we want to try or catch unhandled exception. But there's a better way to this approach. We want to handle errors globally with built-in middleware. So basically, we create an extension here that we register using exception handler middleware, and we inject into our API project or applications. Now we can have a cleaner way to handle API exception. We don't need to write all the try-catch block in all our API functions or action code. So our action method becomes much cleaner, and more importantly, we can reuse this functionality to write more readable functions or actions or API in future. Since we know proper error handling is an important mechanism in API application, we cannot miss out logging the exception somewhere. It is equally important mechanism to be in place. So logging mechanism is not just to log any possible or unexpected exception. It is a critical and essential part of software, especially when we plan to publish our application to a UAT staging or production environment. Log messages will be useful and helpful for us to check and analyze how well our API or applications behaves or function when it's deployed to staging or production environment. It will help us to investigate the essence of the problem. So in this example here, I'm showing you Serilog or Nlog logging framework for Microsoft.NET technology. But the two main elements that is required in every logging configuration, they are the targets and the rules. The targets will specify where you're going to log to a file or log to a database. And the rules will determine the different levels of the log you want to capture. And all this can be done through a configuration file. I'll show you an example here, error 413, request entity too large. It usually occurs when a request made from a client is too large to be processed by the API server. This commonly happens especially when fetching images or huge record set of entity objects. Web servers place a size limit on upload responses to prevent user from overwhelming the server or exceeding the storage permission. So this is also to prevent DDoS attack that can be caused by huge API requests to the web server or API server. Other aspect that you need to consider will be if your API call is going through CDN or API gateway, you might also want to check that your CDN server or API gateway doesn't impose file size limit that are too small. Another key aspect to how to handle API failure here is to enable API to handle transient failure when it tries to connect to a service or network resources by transparently retrying a failed operation. This will improve the stability of the application. So Poly is a .NET library of functions that provide resilience and transient fault handling capabilities by applying policies such as retry, circuit breaker, isolation, timeout, and fallout. It is also one of the methods that we can use to ensure microservices resiliency and fault tolerance by applying retry and circuit breaker patterns. So in case of a high concurrency and scalability under high contention, so a good workaround is to use a jitter strategy to apply to the retry algorithm so that it can smoothly and evenly distribute retry intervals applied within a well-controlled medium initial retry delay on an exponential backoff. This approach helps to spread out the spike when the issue arises, thus improving the overall performance of the end-to-end system. Transaction management is very important. Let us consider the unit of work which span one piece of business logic, such as creating a user, checking out a card, and processing an order. We want to wrap this piece of logic in one single unit of execution so that if something goes wrong, you can undo all the changes or modification to the database and try again. And this is known or what we call database transaction. The unit of work encompasses the business logic in the transaction to commit and save the data to the database, or roll back or discard changes in case there's a failure at any point of the business logic. Pagination is also a very important concept in building API. We don't want to fetch all the records, millions of records in the database all at once. This can cause payload to huge error, which I talked about or shared earlier. So not only that would be an extreme effective way to return results, it will also possibly have devastating effect of the application itself or the hardware it runs on. Client and encounter memory resource crunches or leak, and it can cause performance issue and in no way optimized for public or private API. It can cause a massive slowdown for our application case in severe cases, thus restricting the number of return records and showing them is very important. So you have to identify the APIs that requires paginations and those that you need not implement pagination. For API that have consistent or huge growth of data over time, you can consider implementing pagination for this API. So two types of pagination here. We have the offset pagination and the cursor pagination. Offset pagination, the idea is to divide the number of return lists into pages, and each page will contain X number of elements, like 10, 20, or 30. And this is achieved through SQL key ability like limit and offset. Limit refers to the limiting the number of elements that is returned from the database, and offset is offset by the number of elements based on the page you are at. Cursor pagination, the reason here is fast and selecting elements, because you, for example, you base on a certain column, right, such as the created on, right, the query the index. The index help to query and jump instantly to the created on to satisfy the condition using the index hash function. So both of these methods have its limitation in terms of time and data complexity. We won't discuss that here, but cursor pagination is most efficient method of paging and should be used wherever possible, but it does not cover all use cases. So both offset pagination and cursor pagination are widely used in different use cases, and you think about which will be the right technique to meet your needs. Filtering is also an important part in the Restful API. Filtering helps to get the exact result we want instead of returning all the results without any criteria. So in certain sense, it improves the performance of consuming API by not returning the entire collection list of records or data. Sorting here will supplement filtering. It refers to ordering the result in a preferred way, right, using query string parameters. So it doesn't really help in performance, but API filtering and sorting will comes together and is a mechanism to retrieve result by providing some kind of criteria. So the filter will be things like your value range, your date range, or specific inputs. When implementing filtering, you always restrict by a predefined set of options that you can set in your request. So this means that it has some coupling with your web application or your UI at the front end to construct the API query that's sent over to the server for processing. So on the front end, which is your web application UI, filtering is usually implemented using checkboxes, radio buttons, or drop-downs. This kind of implementation limits you to only options that are available to create a valid filter. So to speed up your API request for data, we could identify API that requires filtering or sorting to be implemented. There are various types of caching here. So firstly, caching can be done at the client applications, right? Like your mobile or web applications. So data like things that seldom change, this will be the most effective approach, right? Such as caching images. But the downside is the server have to respond to at least one request per client. Right? The second method of caching will be at the cloud front. Right? CDN has built-in caching capability. So caching at the edge is very cost efficient, and it cuts off most of the call to the other backend like your API gateway and your Lambda, which is your API server or host your API. So it improves the end-to-end latency and user experience. We need, and also we need not built-in application code that need to enable caching in this case. Thirdly, we can cache at the API gateway. CloudFront will only cache response such as your get, head, and options. But your API gateway will be able to cache responses other than with different request type like your post, put, or delete. So you have flexible option to cache. So you have to choose which path and query string are included in the cache key. But the downside of API gateway caching is you switch from a pay-per-use pricing to a pay for uptime, because there is a mem node that is required to manage the cache data that is handled by the API gateway. Fourthly, we can do code or application level caching. So cache data is only available for the API server. There is no need to share them across all the concurrent execution of a function. So the overall cache miss, as discussed before, is pretty high. The first call to the API server will always be a cache miss. There's the downside here is if the API server resets or recycle, the cache is lost. So we have this distributed approach, which comes to point number 5, distributed caching. So if you're using AWS, you can use Elastic Cache or the Dynamo Accelerator, the DAX. The good thing is not affected by API server recycled. You pay for the uptime for the Elastic cluster or the cache node that's managed by the database or the DynamoDB. Another way to improve performance can be through GraphQL. So GraphQL is a query language for API and runtime for fulfilling queries with existing data. The advantage is it allows client to have control over what is required. You can control the request and response. So client will customize the GraphQL query and send to your API to get exactly what you want. So instead of traditional API where you probably send multiple requests to fulfill different request needs for a page or a screen, so client can get as many resources in one single request through the use of GraphQL. So other technologies, new services that are available will be things like your GPC. It's modern, it's a lightweight communication protocol, provide greater performance at the expense of less flexibility. So the advantages of over-REST is that it's robust because it defines a specific set of rules for each request and response. The usages of gRPC will be for microservices, client service application, integrations, and API. The details of it, I'll not go through it. So GraphQL originates from client-driven or from mobile application. So some of the comparison here, in terms of caching, it might be hard to catch because there's dynamic query that's formed at the client side. So comparing with REST, right, by virtue of fact, they always return the same field, so therefore it's easier to cache. So if your application or your screen requires a lot of query to different set of data, then GraphQL is suitable. However, GraphQL has its overhead and difficulty in the implementation. But the good thing of GraphQL is that you only just need to work with one endpoint, unlike you need to call multiple API endpoint using REST API. So this make a good performance improvement using GraphQL comparatively to REST API for applications or pages that requires data from multiple sources. So I hope that this has given you a good understanding on selecting the right services for your design. So gRPC is lightweight, we talk about it. Testing is actually one crucial aspect to ensure quality software. API layer of any application is also one of the more crucial software component because it is a channel which connects the client to server that drive the business process and provide the services that add values to customers or your partners. So a customer-facing API, right, that is exposed to end user become a product itself. Therefore, if it breaks, it is put at risk, not just on the application, but also the entire chain of business processes that's built around it, and it also damages the customer experience. So there are some few key things that you need to know, very important in API testing. Number one, for functional testing, we want to ensure API functions correctly, so there's no bugs. It works according to the requirements or the API interface specifications, which is your API documents, right? And it prevents regression between code mergers and releases when there are different versions update to the API. Number two, you want to check the API specification as API is a contract. So API essentially is a contract between the client and the server. We want to make sure that the contract is correct by inspecting the spec through, let's say, your Swagger interface or your open API references. This is important because if it's a customer-facing public API, this is your last chance to ensure that all the contract requirements are met because once the API is published and in use, any changes you make will break your partner's code or your customer code. Most importantly, number three, we want to have an API test plan. We should have some form of detailed test plan that can be expressed as metrics for comprehensive test automation or manual testing of our API. So testing can be done in isolation. This is the bare minimum that we should start with, and executing a single API request and checking the response is correct. So there's no reason that we will continue the API if the test fails. Number two, multi-step workflow with server requests. So for example, we can execute a post request to create a resource or a data in some database, and it will return some auto-generated identifier in the response based on the created resources. We will use this auto-generated identifier to check that if the resource is created or present in the list of elements using a GET request, and then we can patch the data using the patch endpoint to update some data, and then we can invoke a GET request again to validate the data is updated. And finally, we delete the resources and we use a GET request again to verify the resource is no longer exists. So this seems like a unit testing that you will require, right, in your API. And third and foremost, which is also very important, is combining the API with your application or your UI. So this is relevant manual or automated testing, right? If you automated, you can use applications like Catalan Studio, right? Here is we need the API to test with the UI because we want to ensure data is integrity and consistency between UI and API. So the right side will show you the list of API to test, followed by the metrics to test in the test plan. We will also need to cover the following non-functional test approaches, which are essentially important for API to ensure API quality. Performance, you can have things like you check for the response time, the latency in various scenarios, in isolation and under load. And we can also have load testing and stress testing to find the capacity limit point and ensure that the system performance as expected under load, and it will fail gracefully under stress. One of the key or common aspects of API is also the security. So the security mechanism of API is to use API through some form of API keys or JWT token. When we do JWT token, there are three key components here. Number one, which is the open authorization, which is a framework to use to get authorization token for partners to consume the API. So you can provide identity to the API provider or the API server through the use of authorization server. You want to validate the valid requests that come in from to access the API with the use of a token, which is what we call the JSON Web Token. It's a part of the OAuth framework. And this token comprises the header, the signature, and the encryption payload, right? And allows client to establish their identity so that they can access secure API resources. And all this comes under the compliance with the SAML, right? Security Assertion Markup standard, which is a single sign-on mechanism when users are authenticated to retrieve a valid token. And then this is the standard to pass the authorization credentials to the API server or the API service provider. So other forms of API security that you should consider and look into will include things like your basic authentication, your username and password authentication, or rule-based authentication using some form of identity management, or security by consuming the API through API gateway with a valid API subscription key and a token. So CORS is also very important. It stands for cross-origin resources. So when a web application tries to call or request for an API using an AJAX request, a pre-flight request is sent to API server. Right? The pre-flight request is asking the server whether the server can handle this request from this URL. So if the server is able to process this request from the given URL, it will respond with an OK. Then the client, right, the web applications through the browser will receive the permission to send the actual request, right? And you await the API response to come back to the applications, where application will take over to process the response. So one key things that we need to take note is that we have to use wildcard for CORS wisely. And this shows some common CORS failure, especially when we develop applications. So CORS failure results in errors for a security reason, right? And the real reason is usually very big and it's not exposed via JavaScript client on your browser. So it can be, so when it fails, right, with the above scenario as shown, right, it might be a pain point, right, for developers to debug or troubleshoot with generic cause error. Payload inspection is another perspective of security that we need to look into. We want to make sure that there's no malicious payload call to the server hosting the API for processing, We will use validation policies to validate API requests and response against the schema, right, and protect from vulnerabilities such as injection of header and payload. So an example is you must make sure that your validation policy only allows JSON schema. So format other than JSON unsupported, and also maybe the request message or body that you send, right, the payload that you send cannot, anything that's larger than 100 KB will be blocked. So this can be done, payload inspection can be done through the API gateway or API management tier. We have also seen some of these techniques and services. Therefore, is REST API style still relevant? From this diagram, we see there's many layers between the server and the end client. So there's a lot to operationalize. However, a big advantage of using REST is the ability to layer and apply cache constraint. So the API management layer was also created to supplement your API applications, your REST principles, and it's not vice versa. Layering is important because it will impact the overall platform architecture. So most platform requires application servers on the backend, load balancers, reverse proxies on the front end, and the ability to push data to CDN on the edge. Therefore, it is very important to properly design and implement your API based on REST principles. CloudFront, API gateway, and the network and API management layer will supplement your API in terms of your code, your cacheability of your APIs. Above and beyond, we don't want to miss out key areas to ensure your API has high availability, performance, stability, and scalability. So API is monitoring is very important. And as your business grows and your platform scale to serve the growing demands, it is very important in some way to think of API as the API economy. So your company need to manage your API for internals and external contexts. Therefore, your company need to think of starting to create API strategy and roadmap for evolution to target the creation of partnership ecosystem with external partners or customers to grow your business and also for business agility. So in closing, API has moved towards an increasingly distributed and decentralized model. API has become an important connection point for interaction and integration between different applications and platforms. We look at some of these aspects of separating API on API platforms, API as a service. We have looked at some important aspects of API management, where API management platform can do, and what API gateway can do and handle. So these are some resources that you might want to check out. It may come in useful when you design or implement your API. So on top of this, you can have some of these, like you can compare between Butter CMS, Sanity, Strap API, Agility CMS. You can check out this platform for managing and hosting your API on top of the major cloud services or partners. Thank you. We have come to the end of this session, and I hope that you find this session interesting and meaningful. I hope you have learned something out of this. I do look forward to more of this session. Right? Yeah. Okay, so this is the time for Q&A. All right, there will be a question that you might be interested, which is how you handle API transactions, right? When your API need to update to multiple database or entity. So a way to handle writing of data to multiple database entity instead of calling multiple RESTful API is you can use what I've just shared with you through GraphQL. Alternatively, when you design API, you might want to consider, right, combining this two API call into a single API call and expose to your customer partner so that you can use a single unit of work to manage the transaction of writing to two database entities. And in the event that there is a failure to write or to commit a record, for example, on creating an order and processing an order for delivery, you will write to an order table and a delivery table. And when writing to a delivery table failed because there is a unit of work there handling the single business transaction as one, it will automatically roll back the records from the both database entity. So that's one of the way to manage database transaction. So in this course, and what we shared here is how you can use API to improve or to build your platform. But in recent years, or in this digital transformation, right, we have also seen microservices arises. So microservices basically was spin off from API. And when we do microservices, we will also need to think about how we handle, right, transactions and failure. So I've shared with you a library earlier on, which is the Poly for .NET library, right? In that case, right, you can use that to handle transaction failures or retries, right, using different strategy. Yeah. Okay. So if there's no much other questions, probably I'll hand over the time to Edgar. Yeah, thank you very much.
Darryl, thank you very much. For everyone in the audience, I hope that you have managed to gain something from this masterclass. And so if you have no other questions on the program, or if you still have other questions, you can let us know. My email I've put into the chat. But if you have no other questions on the program, the next grad cert for architecting scalable solutions will be starting on January 8th. So right now is the time to go and sign up for it. And you can find out more about the course fees on the website. Like I mentioned, for Singaporeans, you get 40% off the grad cert course fees. So if you have any other questions, let us know. Otherwise, thank you very much for joining us today.
Thank you, Edgar, and thank you, Darryl, for being with us today and for your valuable sharing. Well, we hope you've enjoyed today's session. We'll now invite you to participate in our feedback poll. Please give us your honest feedback so that we can further improve on our brown bag series. The feedback poll should be popping up on your screen, so please take a few moments to share with us your observations. Thank you for your feedback and for joining us today. This Brown Bag series is proudly brought to you by HeadHunt in partnership with NUS Institute of System Science. This marks the end of our NUS-ISS Stackable Programs. Please look out for a new Brown Bag series on lifestyle topics happening on 2nd of December. Please sign up early on our website, masterclass.sg. On behalf of HeadHunt and NUS-ISS, we'd like to wish you goodbye. Bye.